So let's understand what electric flux is basically. Okay? So as I have discussed the electric field lines, so electric field line is a concept to basically show the electric field strength in terms of lines. So this is an imaginary concept that we use to represent the field strength because electric field is a non-contact force. There is no contact between the bodies, right? So we need an basically electric field lines concept to show that. Yes, Abyaz, that is the point of view of the electric field lines. Yes or no?
Yes, sir.
Okay. Right now, so same thing. So now the next thing that comes related to the electric field lines is called electric flux. So basically, what is electric flux? Let me give you an idea. Suppose that, like, here it is. Okay. Suppose that this is an, you can say kind of surface. Clear? Is that clear?
Yes, sir. Clear.
Okay. So, like, so this is the, so if this is a surface, so that means this is a total area that is being inside this box. Yes or no, Abhyas?
Yes, sir.
Okay. So that electric flux is basically the number of electric field lines passing through this area perpendicularly, normally. That quantity is called electric flux. You can see this thing. So whatever the number of lines are passing, electric field lines are passing through this area perpendicularly, normally. It should be normal. Okay? So those lines, so that quantity is called electric flux. Is that clear, Abhyas?
Yes, sir. It's clear.
चलो that's great. ठीक है. So it's nothing but the E vector. It is the electric, basically electric field vector. ठीक है. So let me basically keep it aside so that I can write it down on the screen. ठीक है. So let me write down the about the electric flux. So electric flux through a given area L inside an electric field is the measure of the total number of field lines. Okay, of electric field lines basically. Field lines of force passing normally through that area. Is that clear, sir, Abhyas? So that's what
Yes, sir.
electric flux is. Okay. And how do we define, how do we denote electric flux? It is denoted by phi. Okay. Okay. So this, give me a second. So it is denoted by phi. And the formula is E, the electric field vector, dot product of electric field vector and the area vector. Okay?
Yes, sir.
And if, okay,
Yes,
so
okay.
that's great. I hope it's clear to you. So ultimately, when you will remove that dot, so it would be E S cos theta. And here the theta is the angle between the electric field and the area vector. Okay? The horizontal component. Is that clear?
Yes, sir.
Any doubt, Abyaz?
I know, sir, it's clear.
Are you sure?
Yes, sir.
Okay. Please note it down and let me know. And if we talk about the SI unit, Abyaz, so SI unit is nothing but, so just multiply the electric field into the area vector. So it would be uh, Newton per coulomb, because electric field is force upon charge, into meter square. Okay. So this would be SI unit are basically two. There are two SI units for the electric flux. Is Newton meter square per coulomb. Okay. Or volt meter. Okay. Is that clear, Abhyas? So these are the two units, sorry,
Yes,
two units of the electric flux. Okay. Please note it down and let me know once done. So if you want to draw this theta value would be like this. Okay. Suppose that an electric an electric field is going like this. So up here and see, okay. So, so in that reason, so this would be your E cos theta. Okay, because the horizontal component is the E cos theta, but this is the angle made with the area. Okay, so you need the and okay, the horizontal component along the field. Is that clear to you, Abhyas?
yes, sir. Clear.
Okay, please note it down and let me know. Done. Okay. So, next last thing about the electric field is this electric flux is it is the scalar quantity. Okay. Here we are
Yes, it's clear.
taking it. Okay. So this was for the plane surface. So suppose that Abyaz, now you have a curved surface like this. Just give me a sec. Just a second. Let me find it. This image. Let me paste it over here. So, so as you can see this thing Abyaz, that it is a curved surface, right? Okay. So what you
Yes,
have to
sir.
do is that okay. So if the curved surface is there, so next thing for when if the area vector will always be perpendicular to the surface, as I have told you. Okay. So area vector will always be perpendicular. Okay. Like this. Because whenever we draw a line on the circle surface, on the semicircle surface, it will always be perpendicular. Yes or no, Abyaz?
Yes, it's always
Okay. This
perpendicular.
is the property of circle and square. Okay. So over here, Abyaz, you can see these are 90-degree angles. Okay. These are 90 degree. And this is area vector. Okay. So it is 90 degree. It is. So over here, what we have to assume is basically an electric field is supposed like this. Okay. And this is electric field. Okay, complete color. Okay. And this is your electric field. And one more. So this is also the electric field is going like this. Okay. So what we are going to do is basically we have to find one thing because it's a closed, it's just a we can say a curved surface. So we are going to assume that a small area called DS element like this. Yes or no, Bias? So whenever we have a curved surface like this, we assume that it's like this. So this is what? This is a small DS element. Okay? Okay. So what is so this is DS. This is small DS area element. Okay. This is what? Small एरिया एल, ठीक है। So the answer would be the part, like you can say the expression would become, so this is a curved surface. So we are going to use the integrals for it. Okay, curved surfaces. So what we are going to use? Integral surfaces. Is that clear, Abyaz?
Yes, yes.
Okay, so that's great. So in that thing, it would be equals to phi is equals to closed integral. Because Abyaz, if we do not consider the closed integral, so the line, because if it's in open, so obviously the area will not be covered properly. Yes or no? So that's why we assume that it is a closed surface, because the line passing through the closed surface should be considered as the you can say electric flux. Okay, and this is what it is called. It is the closed integral. Whenever integral and circular sign, this is your closed integral. Clear, sir? Oh, Abhyas, closed surface. Okay, so this is denoted for the closed surface. So and this would be E dot ds. Okay, I hope it's clear to you now. Any doubt?
Sir, no, sir, no doubt.
Sure, sure,
Yes, sir,
Abhyas.
sure.
ठीक है, ठीक है. Okay, so let's do one question. Just give me a second. ठीक है. So here is it. So let me paste down the question in front of you. Let's see how to solve the question. Okay, so Abhyas. So after that, we'll also do the Gauss law as well. Okay. Right now, let's understand what it is saying. The question is saying that if if E vector is 6 I cap plus 3 J cap plus 4 K cap, calculate the electric flux through a surface of 20 units in YZ plane. Clear, Abhyas? What is the question is saying? So it would be,
Yes,
okay, so let's solve. Okay. So first of all, let's write down all the values given to you. Okay, it is equals to 6 I cap plus 3 J cap plus 4 K cap. Okay. And the area is given to you 20 meters square. Okay, Abhyas, if the question is saying, if the question is saying area vector is y along y z, that means, okay, so if that means this is suppose y, exact y axis, okay, and this is suppose z axis, okay, like this. So could you please tell me, Abyaz, that where will be the third axis?
Uh, so the third axis will be the X.
Could you please repeat?
Third axis will be the X.
X. So Abyaz, could you please tell me it's which axis, which I cap, oh, sorry, which vector, not I cap, which vector, unit vector will be perpendicular to this surface, which is striking. So it would be I cap, yes or no? Like this, it should be coming outwards like this, yes or no? Because we have three axes. If y and z are these, so third would be coming outwards, that, yes or no? So that is I cap, isn't, is it yes or no?
Yes, sir. Yes. X.
Okay. So that means, so this is your unit area vector appears. That means the area vector would be S would be just a second, S would be equals to 20 I cap, because we know that the area vector is always perpendicular to the surface. Okay. So that's the only vector. So that means Abhyas, as per the question, flux is basically of E dot S, yes or no? So it would be 6 I cap, 6 I cap, 3 J cap plus 4 K cap dot 20 I cap. So Abhyas, could you please tell me how to multiply it? Do you know how to multiply these vectors if the dot product is there? Hmm?
So 6 I cap into 20 I cap.
20 I cap. And what will be the remaining portions? Will it be there?
So it will remain the same.
No, it will not remain same, because Abhyas, 0 J cap plus 0 I cap. I can write this thing as 0 I cap plus 0 J cap. So multiply with them. It would become 0, 0 J cap,
And the
0
0 K cap.
K cap. So if whenever it is written like this, so you have to use like this. Okay. So dot product says x should, the I cap should be multiplied with the I cap. So that means it is equals to 6 into 20. So it's coming out to be 120 Newton meter square per coulomb or voltmeter. Okay. Please do let me know, Abhyas, is that clear to you or not?
Yes, sir, is clear.
Okay. So instead of like this, so because units are given us, let's write down units only, because no specific unit is given to you. Okay. So only units are given, so it would be units. Okay. So please note it down. Okay. And if I give you one question, would you like to try, Abhyas?
Yes, sir. I'll try.
Start. Did you get everything so far, Abhyas?
Yes, I understood this question.
Take it, that's good. So please note down this question and let me know the answer, which answer you are getting. Any answer, Abyaz?
So can you explain this question?
How it should be. Correct. Like, anyways, basically, question is saying that a circular plane is there, a plane sheet is there, circular plane sheet is there. So plane sheet is already mentioned. That means the sheet would be like this. A small portion is taken over there. Okay. So a circular plane sheet of radius 10 centimeter is there in a uniform electric field of 5 into 10 to the power 5 newton per coulomb. Making an angle with the field, calculate the electric flux through the sheet. So Abhyas, the circular area is like this. Okay. So it Abhyas, so the and basically the front side of the circle is completely plain now. It's like a plane surface. So the area vector would be like this, yes or no, Abhyas?
Yes,
Perpendicular to the plane surface. Is it so, yes or no? So if I draw it like this, so you can also show that like thing. Okay. So this like this is just a second. Let me show that to you how it would be like this. So this is a plane circular, and this is a plane surface. Okay. And the electric field is making 60-degree angle. Okay. So that means the angle, this is the area vector. So this is the theta. What is the value of theta, Abhyas? Could you please tell me?
angle theta 60 degree.
60 degree. Okay. So this is the angle. So this is 60 degree. This is E vector. Okay. So that means this is your okay, area vector, or you can say L. So, so this question says that we have to find the electric. So first of all, let's calculate the areas. Abhyas, how to calculate the area of a circular sheet? Could you please tell me? Its radius 10 centimeter is already given. So
So
first,
circular,
yeah, how to calculate the circular area, circle area. So it would be 0.100, so it would be 0.1 meter. Okay. So area would be, so Abhyas, area is pi r square of a circular sheet.
yes sir.
Is it so, yes
Yes.
or no? Okay. Just a second. So radius making with the field. That would be pi. No, this is not even bad. I just made a mistake. This is not 60. The question is saying that the making an angle 60-degree with the field, a circular plane sheet. So this plane sheet is making the angle. So this is basically like this. So this, if you take a line that is passing like this, okay. So this is the plane surface. So this is the 60 degree. Okay, I just mistakenly wrote. Read the question. Wrong. So this is 60. So Abhyas, in total it's 90 degrees. So this angle would be 30 degrees. Is it so? Yes or no? So the angle between electric field and the area vector is 30 degrees. So area would be pi r square. So 3.14 into r square is 0.1 square. So this is coming out to be 0.01 into 0.01 meters square. Okay. So now let's calculate the. So it is E dot S is equals to S cos theta. E is 5 into 10 to the power 5 into 3.14 into 0.01 into cos theta is 30 degrees, so it's cos 30. Okay. So substitute. What is the value of cos 30, Abhyas? Could you please tell me?
Cos 30 root 3 by 2.
Cos 30 is root 4 of the value. Okay. So you can see the thing, Abhyas. So two decimals are there and two more decimals are there. That means if you multiply it with these two values, so basically basically 10 to the power 4 will get cancelled out. Yes or no, Abhyas? Because two decimals are there, the 2 into 2, 4 decimals ultimately. Okay. So that means 10 to the power 4 will get cancelled. What is left? 5 into 10 into 314 into 1 into root 3 by 2. This will cancel this 5 times. So when you will substitute all the values, the answer comes out to be 1.36 into 10 to the power 4 Newton meter square or voltmeter. Is that clear to you, Abyaz? Please do let me know.
Yes, yes.
Take it.
So finished.
Correct? That's great. See. So just let me give you one question. Okay, we have now try to solve this question. Let me know the answer. Similar question that we have done just right now. Okay, please try to solve these questions.
Sir, I got the surface area of it.
Could you please repeat?
Sir, I got the surface area in this question.
Surface area.
Yes, sir.
Surface area is 10 centimeters square, na?
Okay, it's given, but I got.
हाँ